So we're going to be talking about regular polygons. Now, this is pretty special because it has a certain characteristics that are true for all regular polygons. But before we get into that one, well, what does it mean by regular polygons? Okay, so it says here, a regular polygon is an enclosed shape with the number of sides that are all the same length. Okay, so a polygon, regular polygon, is something that has a number of sides, and what's so special about it is that all the sides are equal. So these are the different polygons. Okay, so the smallest number of sides in terms of polygon is a three-sided polygon, but we don't call it three-sided polygon, right? What do we call it? It's a triangle, and to be specific, because all three sides are equal, it's an equilateral triangle, right? We don't say three-sided polygon, we say equilateral triangle. Now, here's another one. This one is a four-sided regular polygon. Well, we don't say that, that's too long. What do we call this? Square, right? Square, because the square has four sides and all the four sides have the same length. And this one, this is a five-sided regular polygon. There's a name for that. It's called pentagon. Have you heard of pentagon before? Where have you heard pentagon before? Huh? In the States. Yes, the Pentagon. Yeah, in the States. Yeah, very good, very good. This one is a six-sided, because there are six sides, regular polygon. But there's a special name for that. It's called a hexagon. Hexagon. And then if you keep going, oh, have you heard of a hexagon before? Okay, where could you see a hexagon? Huh? A stop sign? Oh, okay. Oh, very close, very close. That would be the octagon. Almost the same. Yeah, almost the same. Just two more sides. Yeah, almost. Oh, wrenches. Yeah, wrenches. Sure. Okay. Yeah. Honeycomb. Yes. Has anybody seen a honeycomb before? Cereal? Yeah. Honeycomb cereal. Okay. Do you know that sometimes in between the boxes, like there's a box and there's a box, in between there's like a honeycomb shape inside? That actually is a structure that kind of makes it stronger. So, yeah, that's pretty cool. Seven-sided is heptagon. Octagon is the 8. Now these ones here, after octagon, that's probably the most common one. And then nonagon, decagon, and yeah, these ones are not super familiar to us, right? So now there are some properties, some characteristics that are shared by all of those. Okay, so this is what we're going to talk about. So in this lesson, we're going to talk about the following. The first one is called central angle. Okay, we haven't even talked about central angle. Just by reading that part, what does that kind of tell you?
The center where all sides bisect each other.
Okay. Okay, okay, yeah, that's right. Center. Okay, what does the word center mean? Means in the middle, right? Right in the center. And then angle. So that means angle at the center. Okay, that's interesting. We're supposed to figure out the size of the angle in the center. Okay, sure, we'll do that. What about this one? Sum of interior angles. What does that title tell us? Sum of interior angles. What does the word sum mean? Sum means added together, right? Okay. All of the interior means inside angles. So that means if we add all of the interior angles together, what are we gonna get? Okay, so that's depends on which figure we have. What about this one? Size of one interior angle. Size of one interior angle. What does that mean? We only want one inside angle. So what's the size of one angle in the inside?
The center from where
Okay.
one end meets a side kind of thing.
A side, yeah, it will meet the side for sure, for sure. Let's take a look at this one. Can we figure out how many? That means number of. And draw diagonals. Okay, we talked about diagonals. Can we figure out how many diagonals are there? And then can we draw all of them? Oh, this is going to be fun. And then the last one, number of, meaning how many are there? Lines of symmetry. Have you heard of the word symmetry means? Have you heard of symmetrical? The same, okay. Mirror image, right? So if we look at a lot of different things, a lot of the structure, a lot of things are symmetrical, right? Here, my cup. How can I cut it if it's symmetrical? Can I cut it this way? Is it going to be symmetrical top and bottom?
No.
No, it's not symmetrical, right? Because this has a handle, this doesn't have a handle. So how can I cut it so that it's symmetrical? Down in the middle, right? Yeah, because now this side is the same thing as this side. Any other way that I can cut this so that it's symmetrical?
This way.
Yeah, I can cut it this way, right? It will split the handle this horizontally, and that's symmetrical, right? Now, if we draw a line on the top of our head all the way down to our feet, they're symmetrical, right? 2 ears on each side, 2 eyes on each side, right? Arms, legs, our body is symmetrical vertically like that. Okay, so that's lines of symmetry. So all of these things we're going to talk about today. Well, we'll see how far we get. Okay, so here we go. So we're going to explore central angle. Okay, central. So if we break this down, this is called center angle. Means angle at the center. So if you draw a line segments from each vertex to the corner of a regular polygon to its center, you can generate called a central angle. So this one here, we're just going to use the pentagon. Okay, we're going to use the pentagon to illustrate these. Oh man, my pentagon drawing skills would be put into action here? Have you heard of, where else can you see pentagon? We used to have this van. It's called Chrysler. I remember it has like a pentagon shape to it. So that's a pentagon, 5-sided. Where's the center? Center is about right here, right? Yes? Center is about there. And if I draw from center there and center there, this one is a central angle. Central angles. So we're supposed to figure out the size of that. Okay, we're supposed to figure out one size of that. Well, how can we figure that out? And is it going to be the same if I draw a bigger? If I draw a bigger pentagon, do you think it's going to change? Or is it going to be the same? Okay, do you think it's going to be changing or is it going to be the same? So here's my pentagon. My center, somewhere there. This angle. What if I create a bigger pentagon? Oh, look at that. It's pretty much the same, right? The angle doesn't change. It doesn't matter how big or small the pentagon is. It's going to be pretty much, it's going to be the same. If I draw even bigger pentagon, now it's kind of looking going crazy here. Doesn't matter, right? The angle is still the same. So how can we figure out this angle? How can we figure out this angle?
You measure the angle and you subtract it from 360 divided by the 4 remaining sides.
Okay, that's kind of interesting. Where did 360 come from? I don't see 360 here. Does anybody see 360 degrees in here? If I stare at it too much, can I see 360? Okay, can you show me 360?
Oh, just if you put all these ones together,
Sure, sure. Okay, can you draw it up?
circle.
Sure. Is that what
Yeah.
is that what you're talking about too?
Yeah.
Now, does everybody see 360? Yeah, okay, good, good. Okay, that's a 360. Yeah, so go like that. So what happens now? So if that's 360, make it there. If that's 360, how can I figure out the angle of just this part? Any idea?
What is the given angle for that one side? What's the given angle for the other?
Nothing. Nothing is given. Nothing is
360
given.
divided by 5.
Okay, now you're telling me something that divided by 5 now. I see now the 360. Everybody see 360, right? Yes? Because you drawn the 360. So now where is the 5? Like, where is the 5 coming from? Number of sides? Okay. Yeah. Is that what you're kind of thinking about, the number of sides? Now, do you see 5? Right? So here, this is a 360. Yeah, so we know that. This part, so this is 1 angle, 2 angle, 3, 4, 5. There's 5 angles that we can split it to. Okay, and it's number of 5 sides because you're talking about this side, right? 1, 2, 3, 4, 5. So now it's 360, and if I divide it into 5 angles, what would that be? 360 divided by 5, what would that be? 72. Okay. So in this case, this is going to be 360 degrees because that's all the way around. And then we're going to divide it by 5 angles because it's right here. 1, 2, 3, 4, 5. And you got 72 degrees. Yeah? That's exactly what it is. So you thought about this formula. C, which is central angle, is equal to 360 divided by n. N is the number of sides, and which is also the number of the angles that we're going to split it to. So this formula will be given to you, okay? But it's a matter of using the formula to figure out the question. That would make sense. It's good. Oh, sorry. Gotta erase this one. That's not too bad, right? Central angle, 360 divided by n. Central angle means coming from the center, from the middle. Oh, okay. Calculate the size of the central angle in a pentagon. Pentagon. Well, what's a pentagon? C is 5-sided, so 360 divided by 5, which is 72 degrees. And then this is the fun fact that you guys did. You figured it out on your own just by looking at it. Okay. Now, let's move on to sum of interior angles. Okay. What does the word sum mean? The total added together. When we put them all together, interior means inside angles. So interior angle in a polygon is the angle formed by the 2 sides. So this is what the interior angle is, right? Interior angles. Interior angles. Do you notice something, or do you wonder something when you see that? Do you have a question? Or do you have like, I wonder? What do you wonder about?
Well, that breaks the 360 rule there, I think.
Hmm?
The sum of all those angles, I think, would exceed 360.
Yeah, it's going to be more than 360. Yeah, it's going to be more than 360. Okay. Can I see some? Can we see something? Okay. Three-sided figure. The sum is what? Sum of the angles?
180.
180. Oh, interesting. We know that, right? A triangle, when we add up all the sides, not the sides, the angles, angle 180 degrees. Yes, we know that. What about this part? A four-sided figure. $360, because 99.90. Okay. Can you prove that this is 360? Because sometimes it's not. Is there another way that you can prove that this is 360 degrees? You're probably thinking, oh, 90 plus 90 plus 90 plus 90, oh, that's 360. But is there another proof that you can have to show that it's 360?
Bisecting.
Bisecting. I'm going to cut this part here. How many triangles can I have? How many triangles can I make? If I cut it this way, how many triangles? I can have one, I can have two. Okay, one triangle adds up to 360, and another triangle adds up to another 360. 180. 180 and another 180. That makes it 360. Okay, now I'm gonna draw 5. Okay, I'm gonna draw 5. Let's see if we could figure out some kind of a rule in here. Okay, so we know a triangle can make 180. So I can draw like this. So one triangle. Another triangle. And another triangle. What do you think that is going to be?
$360 plus 180.
360.
Plus 180.
Okay, because this triangle has to be 180 degrees, yes? And then this triangle has to be another 180 degrees. And then this triangle has to have 180 degrees as well. Okay, so what would that be?
440.
540. 540. Do you see a pattern? What do you think it's going to be, the six-sided? Two, three, 4, 5, 6. Yeah, it's all about the patterning. Do you see the pattern?
There will be 6 triangles.
How many triangles can you make with this one?
They all increase by 180.
Oh, you got it.
What's that?
Say that again.
They all increase by 180.
Yeah. You put another side, it increases by another 180. Yes. Can you see? Okay, now you've actually told everybody. Can you see that this is, oh, I gotta add 180 to get the 360. Add another 180 to get 540. What would this be?
That was an 80.
So another 180,
Oh, never mind. Sorry.
720.
720. Yeah. Yeah. Yeah, that's okay. No, that's okay. So you keep adding a 180 because you're gonna end up creating another triangle here. Let's see. We can make another triangle. So six-sided, you can make one triangle here that makes it 90 degree, 180 rather. 2, 3, 4. So 1, 2, 3, 4. So you're gonna have 4 triangles, 4 180s to get one 720. Now, how does it all fit together? A 3-sided will give us 180. A 4-sided, how many triangles can I make with this 4-sided? 2, right? How many triangles can I make with a 5-sided? 3, 1, 2, 3. How many triangles can I make with a 6-sided? 1, 2, 3, 4. You see that what's happening? 4 and 2, 5 and 3, 6 and 4. What's a connection between these two? 4, 2, 5, 3, 6, 4. You're probably thinking, oh, it's always 2 less, right? Whatever the number of side is, it's always 2 less. Always 2 less. Okay, now let's put it together. Here we go. Remember I said there's always 2 less, and the number of sides minus 2. This part here will give you the number of triangles that you can make. And remember, each triangle has a 180 degree angle inside it, so times it by 180. So the sum means all of the interior angle added together will give you 180 times n minus 2. Or n minus 2 times 180 will give you the sum of all the angles in that polygon. So let's take a look at this one, pentagon. N is equals to 5. So if we go sum, S is equals to 180 times 5 minus 2. So S is equals to 180 times 3. 180 times 3 is 540 degrees. Okay. Again, that formula is going to be given to you. That's for all of them. Now, if there's five of the angles, to figure out just the one, we're gonna go sum of interior angles divided by n. That will give us the one interior angle. So 540 divided by 5, because there's 5 angles that we're going to divide it equally by, so that's going to give us 108 degrees. So each one is 108 degrees. Okay, I'm gonna stop right here. So tomorrow we will continue.